right, so in this video, we're going to be practicing some examples for simplifying expressions that have exponents. Like for this case here, I want you to notice that inside the parentheses, because we usually try to simplify anything in the parentheses first, I can't combine anything. Like this a and b both have different bases, so I couldn't combine these exponents. So the next thing I need to consider is this 5 that's being outside. So anytime we have an exponent that's outside, we need to multiply it with all the exponents that are inside. So, and when I mean by every exponent, I do mean every exponent. So it's going to go to the 2, it's going to go to the 3, and it's also going to go to the 4 because the 4 is also holding a power. Can you guess what power the 4 is holding? It's to the first power, right? Think about it. If something doesn't have a power, it's always to the first power. Like anytime we write x, it's always considered to the first power if there's not an exponent there. Same thing with if you have a 3, it's always to the first power if there's not an exponent there. So once we've established that, we're going to multiply the 5 to all the exponents. So this 4 is now to the 5th power. This a is now to the 10th power, and this b is to the 15th. All right, so from here, you couldn't combine the a with the b because they're different bases, but you could try to take 4 to the 5th power, and this is where you want to definitely use a calculator. So you can use a scientific calculator, should be able to put in the base and the 5th as an exponent. And I'll show you here how to do that. But you can also just take 4 and multiply itself 5 times, and that's where you'll get about 1,024. And then the a to the 10th power comes down, b to the 15th comes down. And I know this answer is done because I have positive exponents, there's no negative exponents, and I can't combine any like terms here. So this is my final answer. So I'm going to now show you how I got this number here. So I'm going to switch my camera over. Give me one moment to do that. So if I were to do video, there we go. Okay, so when you go to Geogebra Scientific Calculator, remember this is on Canvas for you guys. Just go to a homepage and you'll find this website, or just Google Geogebra Scientific Calculator. You'll find this easily. You'll need to click in this here. That will help you get your base and then the exponent. So if you click on this, you should be able to write in your 4 and then click on that part and you can put in your 5. And so that's how I got 1024. And that's it. So I'm going to pause it right there. And if you need to reference on how I do that, and this wasn't a very clear video, feel free to watch some YouTube videos. You should be able to find how to put in exponents on a TI-84 calculator, normal calculator, or anything that's online. Feel free to use calculators for this homework. So let's move on to the next problem. So for B here, I want you to notice that that both the top have the same bases, and this has a division line or fraction. So this is probably using quotient rule. And you might remember whenever we're dividing, we have to subtract the exponents. So that means that I have to take the top, the 8, and subtract it with the 6 that's on the bottom. So this causes it to be x to the 2nd power. And that's it. And I can't combine anything, and I already have a positive exponent, so this would be my final answer. So that is B. Let's take a look at C here. So C gets a little bit more complicated. The only thing that I could do on the inside here is maybe divide the 4 and the 2. So I'll do that first. Let's think about it for a moment. So the number that goes into 4 and 2 are 2. 2 goes into 4, let's see, 2 times, and 2 goes into 2 1 time. So if there's a 1 here, it's a little bit redundant. So I'm not going to write the 1 anymore. So I really have 2 on the top instead of the 4, and a to the 3rd power. 2 is still outside, and b to the 4th. So I didn't write this 1 here just because 1 times b to the 4 is just b to the 4. So I've reduced the 4 and the 2, and now I just have the 2 on the top. And I can't combine a with b, so I'm not going to. So the next thing I have to take care of is this 2, the exponent. Now here's the thing. If you have an exponent for a fraction, you have to give the 2 to the top and to the bottom. So this 2 goes to the 4 for this exponent that's on the b. And this 2 will also go to the 2 that has a 1 as an exponent, and also to the 3 that has the exponent for the a. Now, if I were to do that, that means I really have 2 to the 2nd power, a to the 6th power, because 3 times 2 is 6, and then 4 times 2 is b to the 8. Now, from here, again, I can't combine a and b, but I can take 2 to the 2nd power, which is 4, and I'm checking to see if I have any negative exponents, but I don't. So this is going to be my final answer because I can't simplify the a and the b. So I'm done. All right, D here. So if I look at this problem, I'm thinking, okay, I can't combine x and y, so maybe I'll just go ahead and distribute that negative exponent inside. And so if I were to do that, I would have x to the negative 12 and y to the negative 21. And from here, I'm like, well, I can't combine them, but I also can't have negative exponents, so I'm going to have to write this as a fraction. So I'm writing this as a fraction because I noticed the negative exponents. So they're both right now in the numerator, so I have to put them in the denominator. So this is x and y in the denominator, and now this can be a positive 12 and a positive 21. And if you guys remember, if I have nothing in the numerator, I got to put a 1 there. So in this case, my answer is actually 1 over x to the 12th and y to the 21st. All right, so let's get into our next set of problems here. So we're still simplifying these expressions that have exponents. So let's take a look at this one here. So you'll notice I have 2 x's here that I could probably work with and 2 y's here that I could probably work with. So that's probably what I'm going to do first. Is I notice that this is a fraction, so maybe quotient rule. And I can combine these x's if I subtract the exponent. So I'm going to try that first. So if I have this x here, I can take 11 and subtract it with negative 3. Now be very careful when you subtract. So I like to write it out when I'm a beginner. So this is 11 minus negative 3. If you don't write it out, you might have missed that negative sign that's right here, along with the negative sign from the quotient rule. And same thing, the y here is taking 10, and I'm subtracting it from negative 1. That's on the bottom. So don't forget that negative sign that comes with the rule that you're subtracting. So from here, this is actually a positive sign that I have. So this is x to the 14th power, and this is y to the 11th power, and they're both positive, so I don't have to worry about negative signs. So this is it. This is my final answer. And I can't combine them because one's an x and one's a y. They're not like terms. All right, so this next one here, I notice that there's a negative exponent, so I do need to take care of that. But I also notice there's y to the 0 power, and we haven't seen a y to the 0 power, or anything to the 0 power. So one of the things I want to remind you guys is that if you have anything to the 0 power, 0 exponent, slash it out and just write a 1. Because anything to the 0 power is just 1. So really what you have here is negative 3x negative 3x to the negative 4th power. And this would have just been 1 times all of it. So it would end up being itself. So you really just have this that's left. And from here, again, remember we have a negative exponent, so we do need to rewrite this as a fraction. And the x will now go in the denominator, so we can write it as a positive 4. And this negative 3, well, it didn't have a negative exponent to begin with. In fact, its exponent is just a 1, a positive 1. So it does get to be in the numerator because it is a positive exponent to begin with. It doesn't need to go in the denominator. So this one is done because I can't combine a number with an x, and there are all positive exponents now. All right, so let's move on to C here. So for this problem, there's a lot more things to combine. Like 2 and 6 can be reduced. So if we think of 2 and 6 as a fraction, the number that goes into both 2 and 6 is 2. So 2 divided by 2 is 1. 2 divided into 6 is 3. So I really just have a 1/3, right? 1 over 3. I also noticed that these x's can be reduced as well or combined. So this x is to the first power, so 2 minus 1 is x to the, or I'll just write it out, 2 minus 1. Might as well be safe and write out the work. And this y is to the first power. And so this would be y minus -1. So if I work this out, I have 1/3 x to the first power, because 2 minus 1 is 1. And this y ends up to the second power, because there are two negative signs, so I add the ones together and get 2. So my answer is going to be 1/3 x to the first power times y squared. You don't have to write that one just because it's a little redundant, but you can leave it there. It's perfectly fine. So you can write your answer like this. Some people write it as a fraction, and they'll write the x and the y squared on top and then the 3 on the bottom. You can also write it like this is fine too. Either one is a correct answer. All right, last problem is going to be this one here. So this is 4x squared y to the 5th power. So on the inside, I can't combine anything because there are no like terms. So I'm going to have to distribute this -2. So this 4 is to the first power, remember that. And then I have to distribute or multiply the exponents. So this will end up being 4 to the -1, x to the -4, and y to the -10. Once I've distributed that, I realize I have a lot of negative exponents, so I have to deal with that. So the first thing I'm going to do is try to deal with the negative exponent. They're all negative, so I know that nothing will be on the top, so I'll just write a 1. So now this 4 can be a +2 squared, x to the +4th power, and y to the +10th power. Now from there, I can't do much because the x and y's don't combine, but I can at least take 4 to the 2nd power, which is 16. And so then I have 16 x to the 4th power and y to the 10th power. And from there, I don't have any negative exponents. I can't combine anything. So this would be my final answer. That's it. And that's it for this video.